cool. Okay. Bon, super. So I think it's 2 minutes after the call bell, so we may start now. So this is our second Ignite talk session. So you know how it works now. So that's still 20 slides, 15 seconds per slide, and they will have to stick to the timing. So this morning the program is to have a first talk about science. Then a talk about, well, I don't know really, but I'm interested to know what you will tell us. And we have a talk about the B612 Polarsys font, which is an open source font. You will have more details later. Something about Papyrus for real time with Charles. And also, so we told him to come with a video, but Sun decided, will you do it yourself? Okay, so Sun decided to do a live demo in 5 minutes. So we will just, that's the last demo before lunch. So maybe if it's 5 minutes and 15 seconds, it will still be okay. But after that, we all leave for lunch. So today we start with Tracy Miranda, who is the program committee chair of this year, and who is also one of the main representatives of the science working group. So Tracy will tell us more about science at Eclipse. I think that's here. Yes, let's do it. Yeah.
Hi, good morning. So, Science at Eclipse. I'm Tracy Miranda, and I have an important message to tell you. And that is, science is real. Please say it with me. Science is real. It's safe to do that in this country. So I think it's something we need to emphasize that I never thought we would. And Science at Eclipse is really, really cool. Say it with me. No, it's all right. Just kidding. So I'm here to tell you all about what we're doing and why it's really, really cool. So the Eclipse Science Working Group, we've been going for 3 years, and our focus is on creating reusable open source software in the scientific domain and any domain really that it applies to. So one of the problems we have is data. Once upon a time, scientists could just do everything by hand or in Excel, but now data is increasing exponentially, and they need the tools to deal with that and to handle it efficiently. Besides big data, we also have these other problems to deal with, and they're not just unique to the scientific domain, but we do want to collaborate and try to solve them. So these are our members, and we really value collaborating at scale. The other thing we really value is the diversity of our membership. We have scientific institutions, we have really big enterprise companies, we have small and medium companies and universities. But what that doesn't show is the individuals who are involved. So we have lots of unique individuals who really make the difference. And we like to keep it fun, and that's our unofficial motto. So we meet as regularly as we can, and in person, like we had a trip to Airbus earlier on Monday, so that's really great. Okay, projects. In the beginning, we had lots of workbenches, and they were all based on RCP and Eclipse technologies like Nebula and EMF. As we came together with our different workbenches, we said, well, like this trend with microservices, can we look and find the reusable bits so we're not reinventing the wheel every single time? And when we looked at it, we said, yes, there are these areas: visualization, workflows, data structures, and scripting, especially with Python, which we all have in common in our workbenches. So what can we do to standardize on projects in that space? So we started focusing on these 4 areas and saying, let's come together, let's collaborate, let's make our tools interoperable by having projects in these areas. And so we did that. And so now we have a number of projects, each under these specific topics. And they're things we're trying to standardize on, bring everyone together, work together to achieve that. So we have a number of projects. Please check out all what we call them our scientific treasures. So they're really worthwhile. I'll mention Eclipse January. It's a project which is what we call NumPy for Java. And we're already seeing some really good success with that because it's been adopted not just in science, but the IoT domain. And Intel started using that for edge processing. So it's really good when something is used for more than we intended. And science has an overlap with IoT. It has an overlap with location tech. Science is everywhere. It's probably in your domain. So you might want to check out our solutions because it might be something that you can apply to whatever you're working on. It's never been easier to start a new science project. We're not just focused on Java. We're not just focused on RCP anymore. Any language, any framework, and we're starting to see real diversification. So our new quantum computing project is an example of that. And more importantly, it gives us an excuse to have a cat and a box. So that's new members. So yeah, check out that project from Oak Ridge. Yes, so science is real, science is fun, science is everywhere. Please join us.
Yes. Stay here. No, stay with me, stay with me. So thank you, Tracy. So at the beginning, Tracy was supposed to be the master of ceremony this morning, but she had to give the first talk. So I think that what I will do is that what we used to do previously is that I give you the ball and I let you introduce the next talk.
Okay, this is something I wish I had at the beginning of my career, a survival guide for being in IT. So please welcome Charlotte Cavalier to talk to us about IT Geek in IT services. Welcome, Charlotte. So, this one?
Hello. I will explain you as an IT geek, I enjoyed my year in IT service company. So imagine you just start your new job in one of the biggest world company, and you discover the organizational chart. It's a huge, fast thing, and you are not on the map. So you start to understand it will be difficult to change anything, but whatever, you get the patience. But you will face some little surprise. First one, 1,200 line function, totally impossible to maintain. A few days after, you discover that your tech lead has been changed to 3 new interns, because for the same costs, they will produce 3 times more work. Or after that, you discover that your new intern don't master the object-oriented principle because they tried to cast something in 2 different types. So it's the start of a new path in your career. First step, denial. You will not believe what is happening, and you hope your next project will be better. It will not happen. And it's where you start to be angry. And you will start to try to do things, whatever it's happening. And it's the path to step 3. The step 3 it's resignation. You start to understand that it will be difficult to feel happy on this new job. So it's the moment that you have to face a choice. Two possibilities. First choice, blue pill, just change, go to a way smaller company and just enjoy your job. Second choice, stay and accept. But what if I told you there is another way? Whatever the structure, whatever the organization, you can fight. And it's what I choose to do. So how did I do that? Well, I think about what I love. Yes, I love to work on new paradigm, but I love to share with other developers. And that's why I decided to create my first Lunch and Learn. A Lunch and Learn, it's just a break for a lunch break where with other engineers, we decide to exchange about a technical subject. And as we are 200,000, we got a lot of people to give some technical subject. And it has been a huge success. I expect only developers, but I got everyone who were interested by this initiative. And it has been the beginning of another thing. After that, we decided to organize an event with our local drug. And it's enabled to connect all developers with the local communities. So you will face some issues. First issue, yourself. You have to go face to the wind, so just do it. It's difficult. The second one is unwillingness. Some people just don't want to change. They love their daily routine, and they don't want that that job will just change. So just go away. If I can give you 2 tips to do that, first one, just don't do it alone. You need to have someone to follow up when we will be disappointed. Other thing, talk to your managers and talk to them in terms I will understand. Explain them that by paying 20 sandwiches once a month, they will motivated guys. So yes, you can do some change, but you will not change in everything, and just keep this thing in mind. So you can't change a project because you got some clients. So what's up now? I don't work in this company anymore, but things keep going. Guys are organizing some party, some rafting weekend, or anything. So if you got an idea, just go ahead. Do things, because there is so much to win for everyone. Thank you.
That's awesome. I love the idea of lunch and learn. That's 2 of my favorite things. Okay. So next up, next up is a really exciting talk because it's not open source software, but something else, an open source font. So I'm really happy to introduce Laurent Spaggiari to talk to us about B612 Polarsys font. Please welcome.
Okay, so it's not too long. Good morning, everyone. I'm Laurent Spaggiari, working for Airbus, and I will tell you a short story about the B612 font. I will explain you briefly why we've done that and how. I will give you some results. I don't care about this, and I will finish with the next to come. So you just have to wait. Yeah. Why a new font? Different reasons, but some of them is for safety, because we don't want to have problems with reading instructions, but also for cockpit harmonization. And as you can see, the current font, it's really old, let's say. So what we've done first is to do 3 different studies and to be able to pick up all the criteria that were necessary for us. And then we transformed these criteria into recommendations for design. And in fact, we had 28 recommendations of 3 different types. And once we've done that, we went to a prototyping phase, mainly in 4 steps, as you will see on the next slide on the right. Here it is. And we had different, well, we tested different things, the way to do the font. And once we've done that, we had a prototype and we go to a test phase. So what we did is to first calibrate the screen itself. So we went from a high contrast to low contrast and vice versa, just to pick up the limits for each subject. And then we tested. And we tested against 2 fonts, the current one and the Verdana, which is a good one. And we had results, and we were able to build up confusion matrix, so we could stick on specific characters to be modified. We did the same test in a simulator, and hopefully we had the same results, so we could keep on working on labs. It was easier and quicker. And we put some complementary tests on contrast and so on. And once we decided we were mature enough, we went to the industrialization phase. So this time we had professionals, typographers, who use the same things, but in a professional way. And they build up 2 variants for us. They applied optical corrections, as you can see here. And the last step, of course, was to validate this, but this time with end users in a real simulator with lighting conditions that are representative of what happens in flight. So that's what we've done. And we added new experiments, such as reading task and pairings, which was really important for us. So pairings was to compare one page with the current font and with the new one. And hopefully the results were quite good, as you can see, for different parameters, safety, reading confirmed, and so on. And also for pairing. The blue is the page is done with the new font. So B612 at a glance. I hope it will come. Yeah, it is. So it's about 600 glyphs. You've got two versions, monospace and proportional. You've got 4 variants. And you got a lot of icons. Oops, it didn't work. Anyway. And you've got, of course, the leaflet, in which you will find what I've told you, plus examples of use. So B612 is used since 3 years now in Airbus. It is since June. It's available for download. And what I plan to do next year is to make some modifications, some updates. So that's all for me. Thank you. And for those who ask, why B612? Well, you got the answer there. Thank you.
Anne, who's a source of lots of wealth of information, has just said, if you have a speaker shirt, we're actually using B612 on the speaker shirt, so you can have a close-up look at that. Okay, next up, talking about what can Papyrus for Real-Time 1.0 do for you, please join me in welcoming Charles Rivet.
I get the ball.
So, ready? And go.
I'm ready? Okay. Hello, everyone. Everyone, can you hear me fine? Fine. All right, who knows about Papyrus RT? Quickly, who knows about Papyrus? A bit more. Thank you, so I don't have to explain a few things. First of all, happy birthday, almost. We're going to release 1.0 on July 13th. So if you're interested, go and get it. It's going to be interesting, and I hope you're going to like it. And for those who don't know, Papyrus RT is really Papyrus for embedded. So you go to top left and you go clockwise. With a bit of steroids added to it because we're much more powerful, with a bunch of less interesting stuff taken away, and then we can use a sonic screwdriver to build Papyrus RT. And yes, it's a very old sonic screwdriver for those who are Doctor Who fans. And that's basically it. What it is on the language point of view is we take UML and we create a superset of a subset. Those who are familiar with SysML will recognize the pattern. But we took a lot of stuff out of UML, all the stuff that people find difficult, we're going to get rid of that, and we create just five different elements that you need to know about. 5 concepts in order to be able to create models for embedded systems and generate all the code for it so that it will run on your platform. The first one is structure, and structure is all from a capsule. Capsule can contain references to other capsules, which we call capsule parts. Capsules talk to each other through connectors that are connected between ports. Ports are implemented using protocols, and protocols is simply telling the port that, well, you can receive these signals and you can send these signals. So it's very simple. You use that concept, you can build very deep structure for all your models for embedded systems. Behavior is a state machine. I'm pretty sure everybody's done a state machine at some point, right? Hopefully. They're simple. UMLs can be complex. Again, we reduce the stuff. We only use what we want and what we need. So basic state machine, hierarchical state machines. We have transitions. You put code in transitions or entry-exit action of the states. And this is the only point where you actually have to know the target language. The target language that we're going to have in the beginning is C++. What makes all of this run is the underlying system. So we have what we call runtime service libraries. It provides all the services in order to be able to run the model. It'll handle messaging, moving messages from one capsule to another. It'll handle running these messages, making sure that they can actually go to the state machine. And it also provides system services such as timing and access to various operations. I mentioned code generation. The only code generation we've got at this point is C++, but the code generator is open source and can be modified. And it's all based using extend, so people in the Eclipse community will recognize how to do that. You can modify the code generation, but you can also modify the runtime system. Again, open source, and all the information is there. Modeling is nice, and most people, when they think modeling, they think graphical. But graphical is not the best way to model in all circumstances. If you want to define the structure of a model, it's very often very faster to do it in text. It's very easy to create a structure in text. So we're going to be providing a beta of a text editor for the structure of a model. We also have the beginning for the state machines, but state machine is typically easier to do within the state machines themselves at the graphical level. Because this is part of the Papyrus family, we're building extensibility in there, and I've already mentioned the extensibility with regards to the runtime system as well as within the code generator. But we are providing also extension points within Papyrus for real-time itself. So if doing embedded system is your thing, you really should have a look at what we're producing. It is free, it is open source, you can modify it, or you can actually ask some people. There are companies out there who provide commercial services around this to help you do this work. If you have more questions, please feel free to come and see me after the talk, or at lunchtime, I will be in the Papyrus Industry Consortium booth, and thank you very much for listening to me.
Thanks, Charles. Yeah, awesome stuff, Papyrus, and happy birthday, almost. Okay, now we're just going to do a quick setup change as we have our Ignite demo. So this is cutting edge stuff here at Eclipse Conference, we hope. But do you need internet? Is setup time counted in the 5 minutes?
Si, c'est ça. En fait, tu prends ça, tu mets ça là. Voilà. Et là, tu branches ton HDMI. Ok. Ouais. So that's the moment when it works or not. Okay.
Okay, we'll start with the introduction. So talking about simplified open source contributions using Eclipse Che, please welcome Santan.
Yeah.
Okay, on your marks, get set,
Yes.
go.
So, hello. I'm Santan. I work at Red Hat, and today I'm going to show you a way we could simplify contribution to open source project with Eclipse Che. And so this is going to be a 5-minute live demo, and we're going to start right away with this simple GitHub project, which is actually a fork of the Spring Technique application. We just modified the README file with this link, this button, and each time someone, a user, a new contributor will click on this link, it will generate a full, complete developer environment in Eclipse Che. So this kind of link is called factory URL. So if we have a look to the URL, there is an ID that we passed as an attribute that actually refers to a JSON file that sits in the Che database. And this JSON file contains all the requirements that are needed to regenerate the developer workspace, such as the Docker images that will contain all your developer tools, such as Git, Maven, Gradle, NPM, and also all the dependencies that are needed to start your application, such as MongoDB, Tomcat, and Node.js, and so on. You will also have some predefined commands that you can set in your factory, such as build and run commands, or the debug mode, run as debug mode. And of course, all the what are needed to clone and import your projects into Eclipse Che. So let's have a look to the generated IDE. So it's starting. What's happening? Okay, live demo. It's breaking. So it's starting the workspace. It's taking longer than expected. So I hope it's gonna work fine. When it starts the workspace, you can also predefine some predefined commands to run when the workspace is starting. So for instance, here, what is going to happen, it's going to automatically start the build and run command. And thank you. So it's going to start the build and run command. as you can see here. If we have on the left the list of all the predefined commands that you can that are being set in the factory, and you can even edit them. For instance, here I can say I want to modify I want to skip the test so it goes faster. Is that right? Yes. I can save it. And each time you are going to run one of the commands, it is also going to make available the preview URL that will give you access to the application. So if I click on this URL, once it's been started, on the Maven is we have downloaded all the dependencies, of course. It will show the application, and we are going to modify. So this is the pet clinic application, and we're going to modify the item view of the list of vets. Oh, okay. Come on. What it is doing? Ah, yes, it's coming. Sorry, I'm so sorry. I know you are hungry, but we have a little bit of internet problems in Amazon. So, yes, this is fine now. This is going to go very fast. So we want to modify this item view, and we want to put the last name in uppercase. As you may know, in France, sometimes we put the last name in uppercase. So I'm going to open the Java project and modify the file. Item view. And I'm going to change the last name and use the underlining, Eclipse JDT to get the code completion. And yeah, that doesn't work.
Okay, I think we're gonna cut you off now.
No. Okay, so it works, and now I can just stop and restart the run command.
One summary sum up.
Can I have 1 minute?
No.
Please.
No. Can
Please,
we have
please,
1 minute?
Yes.
Let the crowd decide. Who says yes to 1 more minute?
Oh, thank you.
Who says no? Okay, the crowd is kind. 1 more minute.
Okay.
Supposed to be in capital letters now.
Yeah.
Okay.
I'm going to open. Okay. So it's supposed to display the this in capital letter. So now we are happy with our changes. We want to create a pull request. There is a pull request in the Eclipse Che when we can give all the necessary information to create the pull request. There's all the simple information to create the pull request, such as a branch name. You will also provide the title. And if you click on the create pull request, it will propose you to commit and then do all the necessary steps to create the pull request. So as creating a fork, push the branch to the fork, create the branch, create the pull request, and then you will have access to the pull request. So you will see in the GitHub project that we have the changes that has been changed. we have our changes. And it will, you can also have the review factory, so the reviewer can review you can open another factory, another workspace without having to clone and set up his workspace every time. And that's all. Thank you. Sorry for the...
So, yeah, gotta love the drama of a live demo.
Just for the record, there's a good reason why we told him to have to create a video. Just,
but yeah,
he really wanted to try it live.
It's not easy, so bon courage.
I can show you later if you like a real live.
Okay, so thanks very much. Thank you very much for being a great and very patient audience, and especially thank you to all our speakers who came up. And now let's go enjoy some lunch. Thanks, everybody.